Yeah, welcome back. We're continuing again. Module 5.4 acid base indicators. You see, you can see the red color here. We're talking about indicators. Red, yellow indicators, methyl orange, methyl red, phenolphthalein, and so on. I hope you're going to enjoy this class. You're welcome. We'll look at introduction, structures of methyl orange and phenolphthalein, acid base indicator chemistry, and we'll conclude. Indicators are substances that change color according to pH of the solution in which they are added. They are used to detect the endpoint of any titration, hence used to test acidity, alkalinity in titrations. An acid-base indicator is a weak acid or weak base that dissociates in water to yield the weak acid and its conjugate base, or the weak base and its conjugate acid. Remember this conjugate acid-base theory. Examples of acid-base indicators are phenolphthalein, methyl orange, methyl red, bromothymol blue, bromothymol green, litmus paper. There are so many of them, etc. We just listed a few here, probably the ones you always use in the lab. Structures of methyl orange and phenolphthalein. We'll just choose these two because we've decided to choose these two because you often see them, methyl orange, yellow form, and phenolphthalein colorless. There are different colors, In fact, if you want to run that as an experiment, if you go to the lab, just get an acid. If you add methyl orange to it, color will change. You get a base, add methyl orange, things like that, apart from just doing your titration. But we'll just use these two, because we're going to use methyl orange to look at the acid-base chemistry. Acid-base indicator chemistry. So most indicators are colored in their undissociated molecule, dissociated or both. Using HIN, that's IN for indicator. H is the proton, that is acid. Remember we said weak acid or weak base. For the undissociated form of the indicator, we can write, look at the acidic character, and then this is the indicator. So the indicator is dissociated into the, therefore Ka for the indicator is this, the same, law of mass action. Now, the numerical values of these dissociation constants can, of course, be obtained by measuring pH of a solution of known molarity for each indicator. For phenolphthalein, we can have, look at it, we have changed this now. pH shows this P and small h here is we're talking about phenolphthalein. So we have this, and the Ka is 7 times 10 to the power 10 moles per dm cube at 25 degrees C. So we also have other values. Litmus, bromothymol blue have their Ka values at 3 times 10 to the power minus 7 and 1 times 10 to the power minus 7 respectively. Of course, every other indicator has its own dissociation constant at any particular temperature. Also, methyl orange has Me, look at it, HME, this, Ka is this, look at the value. We can use methyl orange to illustrate the mode of action of indicators. The colors of the species are, undissociated form is red, in acidic is colorless, in basic is yellow. That's what this means. Now, addition of acid, look at that, look at this equation 4 properly now, that's what we're using. Addition of acid, that's H ions, displaces the equilibrium, equation 4, to the left, so that the concentration of this will be greater than the concentration of this. As you're adding more of this, Letotalas principle, there will be more reaction between here and more concentration of this. So this will be greater than this, and the solution becomes red. The solution will be red because this is a greater quantity. On the other hand, when a base OH is added to the solution, it removes hydrogen. So when you add OH, it removes this hydrogen, and the reaction goes to the right. And the equilibrium goes to the right in order to replace some of the hydrogen ions. So this Me, that is this, will be greater than HME, and it will become this color yellow. That's exactly what happens. In titration, the aim is to determine the volumes of two solutions which just react with each other. This is the equivalence point, and this must coincide with the end point at which titration is stopped. Therefore, the indicator must change color sharply at the equivalence point on adding a single drop of acid or alkali. At the exact endpoint, the color of the indicator will be midway between the acid color and the alkaline color. This means that HIN will be equal to IN minus. Putting equation 5 into equation 2, we have that at the endpoint, look at it, when it is equal, we now cancel out and we have this remaining as equation 6. Therefore, pH at the endpoint minus log this, since this concentration is equal to this, then it means minus log Ka of the indicator. You see? So the pH at any endpoint, we have values phenolphthalein 9.1, litmus 6.5, bromothymol blue, and so on. So we think about the indicators, the change color. Of course, we've gone through this before. Added acid, vice versa, the equivalent point must change sharply. The change in pH during the course of titration, we're just trying to, emphasize on all this. Therefore, for titration involving a strong base and a strong acid, the pH changes from 3.5 to 9.5 at the equivalent point. Any of the indicators, methyl-orin, bromothymol blue, is suitable, since their pH ranges 3 to 4.5, 6 to 7.5, so it's within this range. Any of them can detect the equivalence point. For titrations involving strong acids and weak base, the pH changes sharply at 3.5 to 7.0. Methyl orange is the most suitable. Look at it. Bromothymol blue may be used. Look at it, 6 to 7.5. But phenolphthalein, no way. Look at it. In the case of titration of weak acid against strong base, the pH changes at about 6.5 to 10.5, so phenolphthalein is suitable. In the case of weak acid against weak base, my brother, no indicator will detect the equivalence point with accuracy. All right, and that's why before we give you titration in the lab, we'll know the kind of whether between strong acid, strong base, weak acid, and so on. And we'll know the kind of indicator to give you. That's where the chemistry is coming from. Thank you. We looked at introduction, structures of methyl orange, phenolphthalein, acid-base indicator chemistry. And I hope you enjoyed the class. Hope to see you in the next class. Thank you very much.